In this video, we're going to build upon what you read in the Reading for Time series to talk about just an overview and what the best practices are to represent time series data. So, as you've read, the important thing to do when you're sorting out what kind of a visualization, what kind of a data relationship that you have, while you're sorting that out, you might need to write out what is being asked for in words. And when you see terms like change or rise or trend, growth, you're probably talking about changes in some value over some series of measurements. So that's a time series analysis. Now, we will be looking at graphs that are not wrong, and in some cases we'll look at some that are wrong, but the line graph is kind of the bread and butter of time series. Probably one of the most common time series representations is of stock prices, and that's obviously almost always represented as a line chart, but it's best for mapping continuous data. When we start having categorical data, things like by month or by year, we'll talk about why a line chart might not be the best choice. Also, we don't really want to do a line chart with 3 or more lines very often. They become confusing, especially if they intersect. When you get beyond 2 or 3 lines, they get messy. When you want to visualize more than 3 series, there's better options or more not wrong options. Things like a stacked area chart or a time series bar chart. So just compare that bar chart with the area chart. They do 2 very different things. It's much more difficult to compare across the various series in the bar chart versus the area chart. In the bar chart, you can usually kind of pick out the trend for, like, for instance, email or organic search, because you can just look at those data points. So I can follow this green for the organic search, but it's real hard when you're comparing maybe these purple lines. You can kind of pick it out, but it's real difficult. All right. Now, over here in the area chart, it's a little bit easier, especially to see the relative size of the different bars, how it's relative to itself. So it goes down a little bit here, but how it goes back up, and then how that green compares with the purple, orange, and blue. Anyway, it's much easier to interpret even this one, but certainly this area chart, than it is to interpret this line chart, right? So again, the line graph is that bread and butter, but an area chart like this is this one's a to 100% chart. So whereas this one is just showing the sessions in just pure numbers, this one's calculated to the 100% line. Now, a bar chart for time series is also not wrong. And in some cases, it might be more not wrong than a line chart. So if you look at this line chart on the left, this implies that there's a steady decrease from 2015 and then a steady increase that's basically never changes slope the entire next 2 years. However, if we look at this data, which we'll do in another hands-on, we will see that there's actually all kinds of shape that's missing from this line because it's been summarized or categorized by year. So we typically, when we're talking about categorized data, we want to use the bar graph. It implies better visually that we've summarized these years, and that we are not trying to imply that there is a particular smooth trend. So again, here's what that looks like month by month, right? So when you're looking at that, um, this line graph, you can see that you've missed a lot of the shape of the month to month variation. Now you can also do some decoration to this. On this one, we had a minimum and a maximum decoration, which we'll learn how to do in the hands-on. And we can do a stacked bar as well. Again, it's really, this is one of those points where it becomes, it's just as much art as science. You know, when you're dealing with three categories, maybe the area chart works better, even when you're talking about categorized data. Now this is by month, and we're showing a lot of the shape of the data, so we really could, if we chose to, do this one as an area chart with lines rather than as bars. But it's really up to you to sort out, is the representation that I'm using either hiding shape in the data that's important, or is it becoming too complex to look at, which this one might be. Now, another interesting not wrong graph for time series is going to be your heat map, right? And it's especially important, especially useful when you're not talking about continuous data, so that where you really just care about summaries by some bucket, right? Whether it's by day, month, or year, or quarter or anything. And also nice when you kind of give an overview of multiple categories. Now here's a great example. This is actually something we'll look at later when we're talking about color. But here's a heat map of polio incidents over time by state in the United States, and it's really done nicely. You can see that there's variation across states and then across time, and then after this vaccine is introduced, those cases kind of fall away. And so some other not wrong graphs might be a stream chart, although this one gets to be confusing simply because there's no x-axis floor, and so people find these somewhat hard to interpret, even though they're kind of cool looking. I tend to encourage you to stay away from them unless you're really just kind of looking for something cool to show. It's harder to interpret than other area charts, for instance. If you're going to use a scatter plot like you do in like Hans Rosling does, you have to show the history. So you have to show the paths of the variables like Hans Rosling did over time. The reason is if you can't see the path, you can't compare this time point with some previous time point. The nested bar chart is just kind of an example, another example of the one we looked at before. I'm just kind of putting out examples of what you could do. There's just lots of choices and lots of thought that has to go into doing a time series, because it's not just throw a line chart out there and be done. Line charts may or may not be the appropriate graph. So here's kind of your rules for time series. Time is always on the x-axis. It's always plotted horizontally. Going back to our Tufte, we maintain consistent scales for the duration of that x-axis of the graph. If you want to show causality, meaning the line bends and you're going to say why it bends, you have to show enough time points before the cause to convince the viewer that the values are different after the cause. All right. And lines that cross are difficult to interpret, so avoid them if you have more than two lines. Stack them up in an area chart or something like that. And always standardize values. Always standardize values where appropriate. So again, animation's a key thing, especially now these days with computers, as far as with time series, but you can't rely on the viewer's memory when using animation. You have to show the history. You have to show the trails. You have to show the previous data. And so that's really it for time series. I'm going to do another video on a how-to on how to do each one of these. But for now, these are kind of your best practices and rules for time series. Obviously, it's not everything you need to know about time series, but you had the reading for that, and I don't want to duplicate the same information that you're getting from the readings.